Here we're looking at example 2 from our 2.2, 2.3 set of notes. We're asked to sketch the graph of this y is equal to negative 2/3 x plus 4 and this other graph x minus 2 y is equal to 6 by identifying the slope and the y-intercept. Well, right now I'm just going to look at this y is equal to negative 2/3 x plus 4. We're going to go ahead and throw him over here. And first of all, what we want to do is go ahead and determine what is the slope and what is the y-intercept. For our slope, that is literally, which is equal to m, that is literally just the number right in front of x. It's not including the x, it's just the coefficient in front of x. So our slope for this guy actually just comes out to be negative 2/3. For our y-intercept, that happens to be this last number. In this case, it's 4. Now, simply writing y equals, or for your y-intercept 4, that would not actually be the correct final answer. Because if you think about it, here's your x-axis, here's your y-axis. It's literally crossing specifically at a point for our y-intercept. So what we have to end up doing is throw in 0 anywhere there's that x. Well, here is a 0, I'm sorry, here is an x. So we're going to end up throwing in 0 for that x. And so 0 times anything just comes out to be 0. We have plus 4. So we end up with 0 plus 4 is just 4. So we end up with this point 0, 4. Now the reason why we have specifically this point instead of just 4 as a y-intercept is because we're looking in... Now the reason why we have this point 0, 4 is because we are actually crossing our y-axis. That's why it's called a y-intercept. So in other words, when we're looking at the y-intercept, we're looking at and seeing where is it crossing this y-axis. Well, if it's in fact crossing this y-axis, our x values are going to be 0. Like, you're not moving left or right any for x. It's specifically going to be at 0 for x. And that's why we could go ahead and throw in 0 for x, determine what is that y value. When you do that, it will honestly just come out to be this last number anyway. So for your y-intercept, at least for y equals mx plus b, it's going to be, you literally just have 0 and then whatever that last number is, in this case 4. So if we go ahead and plot that point 0, 4, there he is, we then have that slope negative 2/3. So we're going to go down 2 over 3 to the right, down 2, 3 to the right. And you can kind of see that they are lining up in a pattern. I've also had students say, well, Mr. B, can you go up 2 and to the left 3? And the answer to that is absolutely. Even you guys can see it is lining up with those other points. So up 2 over 3 again. There he is. So now just connecting the dots, you should end up with an image that looks something like this. Now looking at this second equation, we have x minus 2y is equal to 6. Well, unfortunately, that is not in slope-intercept form. In other words, it's not in that y equals mx plus b form that we're so familiar with. And as a result, we have to kind of get it into that form. Well, as we can see, we have y equals mx plus b. Y is actually gone ahead and solved for. And as a result, we have to then pretty much do the exact same thing. We have to solve for y. That's why in the first chapter, we kind of focused on solving for a variable, especially when we had like 2 variables. So we're going to accomplish that by first subtracting x from both sides. Once we do that, we have negative 2y on the left side by himself equals negative x, negative 1x, plus 6. We couldn't combine these two because this guy does not have an x. Now, since we just want y, we don't want negative 2y. That negative 2 is stuck to that y. We have to get him unstuck by dividing both sides by negative 2. So on the left side, negative 2 cancels out with the negative 2. So you're left with just your y is equal to. When we divide this entire thing by negative 2, essentially what you can do is break this up. So we're going to take that negative 1x divided by negative 2. A negative divided by a negative comes out to be a positive. And then we have 1 divided by 2. That's just going to be 1/2. And then our x just kind of drops down as well. Likewise, since we are breaking this up, we want to find that y-intercept, so we're going to take that 6 and divide it by -2 as well. So positive divided by negative, we're going to get a negative. 6 divided by 2 would give us 3. So there it is. We have it now in y equals mx plus b form, such then that we can actually identify the slope and our y-intercept. Our slope for this particular one just comes out to be that coefficient in front of x, so 1/2. And for our y-intercept, here he is. But again, it has to be a point, so it's 0, -3. Again, if you just throw in 0 here, this guy would just be 0, -3, you get -3 as that y value. Going ahead now and graphing that, we have 0, -3, which is this point right here. That is, again, our y-intercept. It's crossing that y-axis at 0, -3. And we have a slope of positive 1/2. So from that specific point, we're going to go up 1 over 2. Up 1 over 2, up 1 over 2. Every single time, up 1 over 2 from that y-intercept. Likewise, you can go down 1 to the left 2. Down 1 to the left 2. And so you should see a graph that resembles something like that. So again, though, that is example 2 from our 2.2, 2.3 set of notes.